Welcome to Chapter 3, Lesson 2 on rational numbers. So we're going to start off with rational numbers. So rational numbers are a big, overarching type. So we're going to start from the middle and make our way out. So starting off, you have your natural numbers, which are like 1, 2, 3, going on, so forth and so on. So those numbers that you learned in kindergarten. Then you have your whole numbers. Your whole numbers include all of your natural numbers and the number 0. So 0 is a whole number and it includes all of your natural numbers. Then you have integers. That's including all of your whole numbers, all of your natural numbers, and now you have your negative numbers added in. And then you have your rational numbers, which are fractions, decimals that terminate, or repeat, and we'll talk about that more later on in this lesson. So if something is a natural number, it is also a whole number, an integer, and a rational number. If it's a whole number, it's an integer and a rational number. So if it's something on the inside, it's also everything else on the outside. So if I have -3, it's an integer and a rational. If I have the number 0, it's a whole number, an integer, and a rational number. So we want to write each rational number as a fraction. I think I meant as a decimal. So we're going to write each rational number as a decimal. So we have 6 and 1/6. So how we're going to do that? Oh no, we're going to write it as a fraction. So 6 and 1/6, we're going to write it as an improper fraction. So we don't want any whole numbers. So how you do that is you take your denominator times your whole number to get 36, and then you're going to add whatever's on top here. So we'll have 37, and then that's over whatever your initial denominator was. So 37 over 6 is the same thing as 6 and 1/6. Then -23. We have no denominator right now, but fractions are dividing, and any number divided by something equals itself, and that would be any number divided by 1. So 23 over 1. So if you ever need to turn a whole number or an integer into a fraction, you just throw an over 1 onto it. So I want you to try on these two and check back with my work. So we're going to have 3 times 4 to get us to 12, plus 2 to get us to 14 over 3. And then we have 7. So with any integer, you just throw it over 1, 7 over 1. Now we're going to work here and we are going to convert decimals into fractions. So terminating and repeating decimals are rational numbers because they can be written as fractions. So a terminating decimal is like this here, 0.64. It comes to an end. So when you read 0.64, the technical way to read that is 64 hundredths because our 4 is in the hundredths place. So how to write that as a fraction is you literally take the number that you have and then you put it over whichever place it is. So it's in the hundredths place, so it's over 100. Then to simplify, 2 goes into both of those, so 32 over 50. 2 still goes into those, 16 over 25. Now we have a handheld video game system weighs 9.675 ounces. Write this as a decimal as a mixed number in simplest form. So 9 is our whole number, so that's going to be hanging out by itself. Then we have 0.675, so it's in the tens, hundredths, thousandths place. So it's going to be in thousandths, and our number on top is 675. So I'm going to start breaking this down Our 9's going to stay. I'm just going to divide by 5 here first. So 675 divided by 5 gets us 135. 1,000 divided by 5 gets us 200. We can go by 5 again. 135 divided by 5 gets us 27. And 200 divided by 5 gets us 40. And I think that's where we're going to stick. So there's our answer in simplest form. Now I want you to try. Write each of these decimals as a fraction in simplest form. So pause and check back with me. So we've got 84 hundredths, so that's literally 84 over 100. We're going to start breaking it down. 84 divided by 2 gets us 42 over 50. 2 can go into both of those. 21 over 25. Here we have 5 and 875, tens, hundreds, thousands. Start breaking her down. I'm going to try 15 here. Doesn't work. So 875 divided by 5 is 5 and 175 over 1,000 divided by 5, 200. Now I can divide by 5 again. So 175 divided by 5. I'm going to erase here. We're going to work backwards. 175 divided by 5 is 35. 200 divided by 5 is 40. I can keep getting smaller here. We're going to divide by 5 again. So 35 divided by 5 is 7. And 40 divided by 5 is 8. So 5 and 7/8 is our simplest form. The last one says rock music accounted for 0.35 of the total music sales in a recent year. Write this decimal as a fraction in simplest form. So we have 0.35. That's 35 hundredths, so 35 over 100. Break her down, divide by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. So 7/20. Now we want to write 0.6 repeating, that's what that bar means, as a fraction in simplest form. So there's a trick to this. This isn't the most fun thing that you're going to do, and is probably the hardest thing you're going to do all year, truthfully. So you've really got to focus and take your time to practice this. So we want to write 0.6 repeating as a fraction in simplest form. So I'm going to go, you pick a variable, I pick n, stands for 0.6, repeating on forever. Because of the multiplicative property of equality, or the multiplication property of equality, if I multiply 10 onto one side and I multiply 10 onto the other side, they're still going to equal one another. So now I have 10n equals, I'm going to distribute here. So if I multiply by 10, my decimal is going to move over. So 6.666 going on forever. Now, if I take away one n, I know up here that n stands for 0.666 repeating. So if I take away n over here, I'm going to point, that's the same thing as this. So I'm going to have 9n equals, when I take away an n, that's taking away 0.66666. So I'm going to have 9n equals 6. To get n by itself, I divide by the number that's connected to it. And so n equals 6/9. So our fraction for 0.666 repeating is 6/9. And just a hint for you to remember forever, any number that's just itself repeating is a ninth. So if you see 0.5 repeating, that's 5/9. If you see 0.3 repeating, that's 3/9. 0.2 repeating on forever, 2/9. So we've got another one to try here, and this is 0.42 repeating as a fraction in simplest form. So we're starting off just giving that a variable that represents it. So 42, 42, 42, going on forever. I'm going to multiply 10 to each side. Because of our multiplication property of equality. Simplifying it, I'm still going to have, 10n equals 4.242. Oh, so correction. I need to get whatever's repeating in front of the decimal. So multiplying by 10 isn't going to work. I'm going to need to multiply by 100 because I want to move my decimal over 2 places. So the repeating part is in the front. So I'm going to have 100n equals 42. Let's make this look nicer. 42.4242. So that this part up here that was repeating is now in front of our decimal. Then I'm going to take away an n, and I'm going to take away an n over here. Our n, remember, is literally the same exact thing as 0.4242. So I'm going to have 99n over here, and taking away an n, that's taking away 0.4242, so I'm left with 42. Then dividing by 99. So we end up with n equals 42/99. And there's our answer. So real numbers, once again, I'm just going to come up here and steal this. This is something that you're going to need to know for a very long time. So if you're confused, I can come give you a crash course on this as well, because it's just something that you're going to need to know forever and reference back to. So here we've got -2 and 6/11. The only category that takes fractions is our rational numbers. So if it's a decimal or a fraction, it's only a rational. This decimal here has no pattern and it doesn't terminate, so it's irrational. 45 is one of those natural numbers. It's just like a 1, 2, 3, 4, 5 going on forever. So if it's natural, it's also whole, it's also integer, and it's also rational. So if it's a natural number, it is everything. So you can go ahead and try these two here. 0, we know, boom, 0 is a whole number. So then that means it's also an integer and rational. 1 4/5, that's a fraction, so it's rational, and that's it. And down here, there's no pattern and it doesn't terminate, so it is irrational.